Hello students, welcome you to this session. Last class we have started matrices and determinants, right? So just to explain what is matrix. Then we studied the difference between matrix and determinants. Then how to expand a determinant, that is the main thing we studied last class. So hope you are remembering how to find the value of a determinant, right? You can expand. 2 by 2 is easy. So just you multiply these two, put a minus, then you multiply the 2. But 3 by 3, you take the first number, leave the row and column, right? You simplify. When you take the second number, you change the sign. That's important, right? And third one, you write as it is. And today, we are going to study some extra things. That is, one is minors and cofactors. So minors and cofactors. So listen carefully, what is minors and cofactors? Suppose a determinant is given. Say 2 minus 1, 5, 4. If you want to find the minor of the first number, minor of 2, what do you do now? Leave that particular row and that column. Leave that row and column. What is left out? 4. And that is your answer. That's all. That 4 is your answer. Suppose I want to find the minor of minus 1. Minor of minus 1. That row and column, you leave it. That row and that column, leave it. What do you have? 5. So that is the minor of minus 1. If you want the minor of 5, can you say what's the minor of 5? So leave that particular row and that column, right? So what is left out? Minus 1. So the minor of 5 is minus 1. Can you find the minor of 4? What do you do? Leave that 4 is here. Leave that particular row and that column. What is left out? 2. And that 2 is called what? Minor of 4. So the minor of 4 is what? 2. So like this you can find minor. Leave that particular row and column. Suppose it is a 3 by 3 determinant given. Say here there is a 3 by 3 determinant, right? 3, 1, 2. 2, 2, 5. 4, 1, 0. So I want to find the minor of 3. So this is determinant A. I want to find the minor of 3. So what do you do? 3 is here. Leave the row, leave the column. Remaining you have a 2 by 2, right? That is simplify. So minor of 3. You can do like that, okay? Then minor of 1. Suppose the question is find the minor of 1. You will have a doubt, right? Which one sir is asking? Because here there is a 1, here there is a 1, right? Suppose if I say minor of 2, still more complicated, right? There are 3 2's. Which 2 we want, right? So what we do normally, the positions we write, the first position A11, second one is A12, like that we write, okay? So the minor of the first element, minor of this 3 means we write M11, minor of the first element. For the next this 1, we write M12, M12. Then for this 2, M13. Then 2-1, right? Second row, first column. M21, M22, M23. Then same way, third row. When you go to the third row, M31, M32, M33. Like this, you can find the denote the minors. But how to calculate? That's very simple. If I want to find the minor of 3, leave that row, leave that column. Take the remaining. And you simplify, directly simplify and write. If you want, you write the step. What is that? 2, 5, 1, 0. And you simplify 2 into 0. 0 minus 1 into 5 is what? 5. So the answer is minus 5. Like this, you can find the minor of every element. Suppose I want to find the minor of then M12, this number. What do? Leave the row, leave the column. Don't change the sign and all here. When you find the value of the determinant only, first one you write as it is, second you change the sign, right? But minor, leave that particular row and that column. Take the remaining. What are the numbers? This 2, 5, 4, 0. 2, 5, 4, 0. Even without writing this step also you can do. So multiply 2 into 0, right? 2 into 0. 0 minus 4 into 5. It is what? 20. So the answer is minus 20. Can you say the minor of the next element? What is the next element? 3. What is the position? 1, 3. How can you find the minor of this one? Leave that row, leave that column. What's the remaining? 2, 2, 4, 1. Directly multiply and say, no need to write this step. 2 into 1, right? 2 into 1. This 2. 2 into 1. 2 minus 4 into 2. It is what? 8. So what's your answer? Minus 6. Like that you can write directly. Now let us go for the next one. Few more we find out. Then later we try to complete everything. Okay. 2, 1. Which is 2, 1. 2, 1 is this number, right? Leave that particular row, that column. Can you find 4 numbers? 1, 2, 1, 0, right? So multiply and see 1 into 0, 0 minus 1 into 2, 2. So what's your answer? Minus 2. So like this you can find. Can you say for the next element? Next element is what? M22. M22 means this position. How can you find the minor? Leave that particular row, that particular column. What is the remaining? So no need to strike out. So initially, so you have to understand properly. Otherwise, just you hide and you can do that. Okay. Or by seeing that, but don't make any mistake. Okay. So these are the elements 3, 2, 4, 0. So multiply 3 into 0. 0 minus 4 2s are 8. 0 minus 8, right? 0 minus 8. So the answer is what? Minus 8. Now 2, 3. 2, 3 means which number is there in 2, 3 position? 2, 3. This 5. How can you find the minor of this 5? Leave that row, leave that column. Can you find 4 numbers? 3, 1, 4, 1. Multiply 3 into 1, right? Like this you multiply 3 into 1. 3 minus 4 into 1. So 3 minus 4 you get 3 minus 4. So the answer is minus 1. Now 3, 1. Now we come to the third row. So third row means 3, 1. Which number is there? 4. We want to find the minor of this 4. Leave that particular row, that column. So these are the 4 numbers, right? So multiply 1 into 5. 5 minus 2 2s are 4. So 5 minus 4. So you are getting 5 minus 4. So the answer is 1. Okay, just 2 more. 3, 2. The next one, 3, 2. So which number is there in 3, 2 position? It is 1, right? So this one. So to find the minor of that one, leave that row, leave that column. What do you have? 3 into 5. 5 3s are 15. 15 minus 2 2s are 4. 15 minus 4. So the answer is what? 11. And the last one, M33. That is minor of the element which is in the third row, third column. Which number is there? This 0. Leave that particular row, leave that particular column. So these are the 4 numbers. Simplify. 3 2s are 6. The order is in my first principal diagonal. 3 2s are 6 minus 2 into 1, 2. So 6 minus 2. So what's your answer? 4. So like this you can find the minor of every element. But one more is there. So minors and what's the next one? Cofactors. So I taught what is minor, right? Now let us see how to find cofactor. So what is cofactor? You know, cofactor is signed minor. Cofactor is signed minor. I'll explain what it is. Cofactor means it is signed minor. We look into the sign also. Cofactor we write C, cofactor, C-I-J or sometimes capital A-I-J, whatever it is. Here the formula is minus 1 raised to I plus j mij. What is mij? It is the minor. So if they ask cofactor, we are writing minor only. But before that something we are writing. What we are writing? Minus 1 raised to I plus j. What is this minus 1 raised to I plus j? It is not going to 20, 30, 45 and all. It is going to give either plus 1 or minus 1. Because minus 1 raised to something. What is minus 1 raised to 1? It is minus 1. Minus 1 raised to 2? plus 1, minus 1 raised to 3, minus 1, minus 1 raised to 4, plus 1, minus 1 raised to odd number is negative, minus 1 raised to even number is positive. So this gives only the sign. This part gives only the sign. So signed minor. Hope you understood why I'm writing like this. Okay, cofactor means minor only we are going to write. But before that we are going to write plus or minus. So that this part divides minus 1 raised to I plus j. What is that I and j? The position aij, right? Suppose you want to write the cofactor of 2, 3, C2, 3. So what do you do? Minus 1 raised to I plus j. Here I is 2 and j is 3. So 2 plus 3. What is 2 plus 3? 5. M23. Minor only you are going to write. Minor you know how to find that. Leave the row and column, write, simplify the remainder. You will get a number. So before that you put plus or minus. For that only this one. Minus 1 raised to 5. Power is odd number. If the power is odd number, negative, right? So your answer is minus of that minor, whatever answer you get, you write. Okay. So now let us see how the sign will be. Suppose it is a 2 by 2. For a 2 by 2 determinant, you know the position, right? For a 2 by 2, you know the first one is A11, A12, A21, A22. So you see the sign. First one, suffix you add and see. Suffix I plus j, 1 plus 1, it is 2. So minus 1 raised to 2. 2 is even number. Even number means it is what? Positive. Next one, 1 plus 2. 1 plus 2 is what? 3. 3 is odd number, right? So negative. Below that, 2, 1. 2 plus 1, 3. Odd number, negative. 2, 2. 2 plus 2, 4. Even number, so plus. So plus, with that you have to attach the minor. Okay, so this gives the sign. Now let us see for 3 by 3. So for 3 by 3, you know the position A11, A12, A13, A21, A22, A23, A31, A32, A33, right? Now see the sign. Suffix you add and see. First you add 1 plus 1, 2. Even number, so plus. 1 plus 2, 3, right? 1 plus 2 is 3. So odd number minus. 1 plus 3, 4. 4 is even number, so plus. 2, 1. 2 plus 1, 3. Odd number minus. 2, 2. 2 plus 2, 4. Even number plus. 2, 3. 2 plus 3, 5. Odd number minus. 3 plus 1, 4. 3 plus 2, 5. Odd number, so minus. 3 plus 3, 6. Even number plus. So it is very easy, no? Plus, minus, plus, minus, plus, minus, plus, minus. So exam hall, you don't need to waste time. 3 by 3, no problem. Just for the first one is plus, minus, plus, minus, plus, minus. Attach minor alone. Okay. Alternatively, you change the sign. Someday they'll ask one particular term alone. Find the cofactor of only that one. Then you go for the correct method. Other things, if they ask you find the cofactor of every element, first you put the sign like what you write in position, right? Plus, minus, like that you write. Then find the minor and attach with that. Okay, so easily you can do that. Okay, now let us see how to find the cofactor of this determinant. Okay, so here 1, 2, 3. So it's a 3 by 3, right? So I want to find the cofactors. Now I said the easy method for this. So it is a 3 by 3, right? So cofactor. So C11, C12, C13. You can write one below the other. I'm writing here. C21, C22, C23, C31, C32, C33. Now you know what is cofactor. Cofactor means it is signed minor, right? So for the first you put plus, minus, plus, minus, plus, minus, plus, minus, plus, right? So now you write the minor. Sign we consider. How we got the sign? You know, add the suffix. If it is odd number, minus. If it is even number, plus. Because the total we are going to write as a power of minus 1. So minus 1 raised to I plus j, right? Okay, 1, 1. See the first number, minor I taught every sum, right? So you know how to leave the row. I'm not going to draw lines and all. So C1, 1 means, so plus already put, leave the first row and that column. 3 is here, no? Leave that row and column. So if you want, I'll show a few. So this is simplified. 2 into 0, 0. Minus 1 into 5, 5. So this you have to simplify. 0 minus 5 is minus 5. Outside plus only, so it is minus 5. See 1, 2. 1, 2 means which one? The second term, right? So you have to leave this one. So leave that particular row and that column you leave it. So already minus is there. 2 into 0, 0 minus 4 into 5. 5 fours are what? 20. So what you get? Minus 20. So it is what? Plus 20. So if you find minor, you get only that minus 20. But when you find cofactor, signed minor, for that particular term, the sign is what? Minus. So minus, then minor value is minus 20. So minus is what? Plus 20. So for the third one, can you say? Third one, this 2, right? 1, 3. Leave that row, leave that column. So 2 into 1, 2, minus 4 2s are 8. So you are getting minus 6, outside plus only, so it is minus 6. Okay. So that is for the third one. Now you try the next one. 2, 1. Now come to the second row. This 2. Leave that particular row, that column. So what you get? 1 into 0, 0. Minus 1 into 2, 2. So what's your final answer? Minus 2 is there inside the bracket. Outside a minus. Minus into minus plus. So the answer is what? Plus 2. So this is the minor for that term. Now for the next one, 2, 2. 2, 2 is the middle term, right? This one. So leave that row, leave that column. So 3, 2, 4, 0. So multiply 3 into 0, 0 minus 4 into 2, 8. So what's your answer? Minus 8, right? It is minus 8 only. Now for the next one, you try to find out. 2, 3, that means this 5. Leave that particular row, that column. So 3 into 1, it is 3, minus 4 into 1 is 4. What is 3 minus 4? Minus 1. But outside there is a minus. So minus 1, so the answer is what? Plus 1. So that's all that row. Now come to the last row. 3, 1. 3, 1 means this 4. Leave that particular row, that particular column. So multiply and see. 1 into 5. 5 minus 2 into 2, 4. So 5 minus 4 is 1. So it is plus 1 only. Now for the next term. So 4, C 3, 2. This 1. Leave that row, leave that column. So what do you have? 3 5s are 15 minus 2 2s are 4. So you are getting minus 1, right? So, but for the examination, you cannot strike out like this. Okay, why I am showing like this for you to easily to understand. For you, what you can do in the answer sheet, just you can hide that row and column or using some pencil and you can do that initially. Then later by seeing that you can write. Okay. Now 3 3. I'm not going to draw anything. And you say 3 3. Which number is there? 0 is there. So leave that row and that column. So that 4 numbers. Can you see the 4 number? Which 4? This 4. Right? Now multiply 3 into 2, 6. Minus 2 into 1, 2. So what's your answer? 4. Like this, you can find the minor and cofactor. Are you thorough with this one? So minor means it's very simple. That particular number, leave that row, that column, remaining you take. If it is 2 by 2, so easy, right? So this is one of the very important thing, how to find minor and cofactor. Even when you go for higher classes, you need this. Okay. So this one you study thoroughly. Next, I am going to teach some of the properties of determinant. Determinant has some properties. Earlier I taught the difference between matrix and determinant, right? So determinant can be simplified. You can be equated with a number, right? It is always a square. Then when you multiply it, very careful. Same way when you take it out also. When you take it out, if something is common, even in one row, you can take it out in determinant. In matrix, you can't do like that, right? And a lot of properties are there for determinant. Let us see a few properties. Okay, listen. So properties you try to understand, because using properties we have a lot of sums. Okay, so try to understand properly, then only you can use that properties, right? See the first property. So no need for proof and all, just you try to understand. First one, the value of the determinant is unaltered. Value of the determinant is unaltered when its rows and columns are interchanged. Rows and columns interchange. In matrix we call it as what? Transpose, right? But in determinant we won't say transpose. We say we are interchanging rows and columns. But same thing only we are doing here, right? Suppose a determinant is given. A determinant is given, say its value is 25. So now determinant, so what we are giving some change. What change we give? We are interchanging rows and columns. We are interchanging rows and columns. You are getting a new determinant, right? So you are getting a new determinant. The value is unaltered. The first determinant value 25 means here also 25. So what you need to understand? Even if you interchange rows and columns, if it is a matrix, everything will change, right? But in determinant, it has a value. The value is unaltered. So that means it remains same. The value of the determinant is unaltered when its rows and columns are interchanged. That is first property. Now let us see the second property. Second property is, if any two rows are of a determinant are interchanged, not all, any two rows, let us see the column later, okay? Any two rows are interchanged, then the value of the determinant changes only in sign. For example, please listen. Suppose A1, A2, A3, B1, B2, B3, C1, C2, C3. This is one determinant. I'm taking its value, say 25. Now what I'm going to do, I'm forming a new determinant. So how I'm going to form a new determinant? Interchange any two rows. In the previous property, you take transpose, right? Interchange rows and columns, columns in rows. That means that A1, A2, A3, you write as column, A1, A2, A3. Second row, write as second column. Third row, third column. No change. Again 25. That is first property. Second property says, one determinant is given, it has some value. For example, it is 25. Now, what change we are going to give? We are interchanging two rows. Either interchange first row and second row, or interchange second row and third row, or interchange first row and third row. For example, here I am interchanging first row and second row. What's the meaning? Second row you write first. That is B1, B2, B3 you write first. Second row you write in that place, A1, A2, A3. So what we did here, we are interchanging R1 and R2, right? Third row no change, C1, C2, C3. How to denote it, you know? R1, R2. This symbol shows you are interchanging R1 tending to R2 and R2 become R1, right? So this is the symbol. The meaning is we are interchanging R1 and R2. If you do so, what happens? See what is given in the property. So interchange, then the value of the determinant changes only in sign. Only in sign the value changes. Actually here what's the value? 25. So here also you get 25 only. But value changes in sign. If you get 25 there, now here your answer will be minus 25. So if we interchange two rows, the value changes in sign. If we interchange rows and columns fully, there is no change. If you interchange two rows, the value changes in sign. Same way if you interchange two columns also. But don't interchange one row and one column. Either you interchange two rows or interchange two columns. The sign changes. Okay, if it is positive, become negative, negative become positive. Suppose two times if you interchange, the two times sign change, right? Minus, one more minus, so it become plus, you will get the original value itself, right? See, for example, suppose you have one more time you change. For example, B1, now I am interchanging these two. So B1, B2, B3, right, as it is. C1, C2, C3, A1, A2, A3. Now, for this you change the sign. Here it is minus 25. That determinant I am giving change, right? Two rows interchanging. So, same value, my same 20 minus 25, but sign change. There it is minus 25. Now it become what? Plus 25, right? And here something I want to give you. Listen carefully. Suppose cyclically if you rotate, for example, you have one row like this, say A1, B1, C1, A2, B2, C2, A3, B3, C3. Say its value is delta. Its value is what? Delta. So A1, B1, C1. So now look only the first number. So A1 means that column fully. B1 means that column. C1 means same that column. So now I'm going to interchange columns. Okay. A1, B1, C1. If you read from B1, B1, then C1, then A1, right? A1, B1, C1. If I start with B1, after B1, C1, again what? A1. If I start with C1, then A1, B1, right? That is cyclically you are rotating. So A1, B1, C1 in this order. A1, B1, C1, or if you start with B1, B1, C1, A1. If you start with C1, C1, A1, B1. Value won't change. Listen, its value is what? Delta. So this can be written in another way. Instead of starting with A1, you start with B1. See again, A1, B1, C1. If I start with B1, B1, C1, A1, right? B1, C1, A1. B1 means that column fully you should write. What is that column? B1, B2, B3. C1 means C1, C2, C3. A1 means A1, A2, A3. The value becomes same. Actually, what happens here, 2 times you are interchanging. If you want, you can check this. See how you interchange 2 times. How will you get this one? B1 here we have first, right? So B1 and these two you are interchanging. So B1, A1, C1. So 1 time interchange. So you will get a minus. Then C1 comes in the middle, no? So interchange these two now. B1 interchanging means C1, A1, right? Yes, that is what you have. So 2 times interchange, minus, minus. So it become what? Plus. Or even you can start with what? C1, right? You can start with C1. Either you can start with A1 or you can start with B1 or you can start with C1. If you start with C1, see the order. A1, B1, C1. If you start with B1, B1, C1, again A1. If you start with C1, after C1, again A1, B1, right? C1, A1, B1. C1 means C1, C2, C3, A2, A1, A2, A3, B1, B2, B3. In all the cases, the answer is what? Same. So cyclically you can rotate the column wise or row wise. Actually what is happening here, 2 times you are interchanging. 1 time if you interchange, you change the sign. Second time, again you change the sign, so you'll get the original value. So here in all the cases, the answer is what? Delta only. So 3 properties, 2 properties we studied. The first one is, when you interchange rows into columns and columns into rows, there is no change. Same answer, same sign. Second property, very important. If you interchange 2 rows, same answer, but the value changes in what? Sign. Only same value, but sign alone changes. 2 times interchange means no change in the sign also. Cyclically you can rotate, that also remember. Third one is very simple property. If the determinant has 2 identical rows, then the value of the determinant becomes 0. Suppose 2 rows are identical. 2 rows are identical. For example, third property. Suppose the first row is 7, 2, minus 4. Second row is 145. 117 by 119. I think now itself some of you are going out, right? Because how to expand this, right? Listen, 172 enough. Then 7, 2 minus 4. What is the answer, No need to do anything, just you put 0, that's all. That is this property says. If 2 rows are identical, the value becomes 0. 2 rows are identical here. Which 2 rows? First row is 7, 2 minus 4. Third row also 7, 2 minus 4. Then you expand and see. You take some simple example and check it, okay? Don't take this 117 by 19 and all, okay? Some simple example, you take 2 rows same. Then another row, whatever you want, okay? Any 2 rows, first row and second row, or second row and third row, or first row and third row. 2 rows exactly the same. Other one, you give some other one. Expand and see, definitely your answer will be 0, okay? So hope you understood the first 3 properties, because when you do the sum, you have to use it. That is why I'm telling so many examples, giving so many examples. Because you have to apply it, that's more important. They are not going to ask, write down the properties. Okay, that also you need. But practical, when you do the sum, So it should come in your mind. If you see somewhere two rows are identical, immediately you should say the answer is 0. Okay. And how to change the sign, how to cyclically rotate, all these things important. Okay, so 3 properties. Let me explain few more properties. As today I'm going to teach only the properties, and next class, based on these properties, we are going to a lot of sums. So I want you to practice it and come. Okay, let us see the next one. See the fourth one. If all the elements in a row of a determinant are multiplied by a constant, then the value of the determinant is multiplied by k. Have you understood anything? If all the elements in a row, not all the elements, in one row, you multiply all the elements by something. So listen, I'm taking the same example. Suppose I'm taking a determinant, say A1, B1, C1, A2, B2, C2, A3, B3, C3. We take, for example, his answer is 25 or delta, whatever it is. Now what I'm going to do now, I'm going to multiply any one row or any one column by 3. For example, I'm multiplying first row by 3. So what do you get? 3a1, 3b1, 3c1. No change in the remaining. a2, b2, c2, a3, b3, c3. Then what is your answer? That answer also you multiply by the number. By which number you multiply? 3. 25 into 3, then your answer is 75. Now read the property again, you can understand. If all the elements in a row are column, okay, what I'm telling for row, it is applicable for column also. If all the elements in a row of a determinant are multiplied by a constant k, here instead of k I multiply by 3, right? Multiplied by k, then the value of the determinant also to be multiplied by k. Suppose one determinant is given, the answer is delta. If you multiply one row or one column by k, then your answer is k into delta. Are you able to understood? Okay. Now see the next one, fifth one. If any two rows of a determinant are proportional, then the value of the determinant becomes 0. Value of the determinant becomes 0. Just now we saw 1. When the value becomes 0? If two rows are identical. If two rows are identical, the value becomes 0. Now one more time, the determinant becomes 0. When? If two rows are proportional. What's the meaning of proportional and what's the difference proportional and identical? Identical means exactly same. Listen. Suppose I'm giving 2 minus 4, 3, 7, 4, 41, 25. Now please listen. Identical means, say I'm taking the first row. Identical means exactly the same number you write. 2 minus 4, 3. Value becomes 0. Proportion means some multiple you write. Suppose you multiply every element by 4. First row fully multiply by 4. What do you get? 4 2s are 8. 4 4s are 16. 4 3s are 12. Now we say first row and third row are proportional. So proportional means some multiple of. Then in this case also the value becomes 0. You know why? We studied if something is common, you can take it out, right? In one row, not for all the elements because it's a determinant. If something is, see in the last row, what is common? 4. If you take 4 outside, the third row become 4 I'm taking outside, 2 minus 4, 3. First row also, 2 minus 4, 3. Second row, whatever it is, 2 rows are identical. So 4 into 0, so the answer is what? 0. So remember, in 2 cases, the determinant becomes 0. Which 2 cases? When 2 rows are identical, the value becomes 0. When 2 rows are proportional, you know the meaning of proportional, some multiple of, okay? Again, the value becomes 0, okay? So these are 5 properties I taught. Now the last 2 more properties, see. Sixth one is, I'll explain the first, then you read it, okay? Suppose first row is A1, normally we write A1, B1, C1, right? Then A2, B2, C2, A3, B3, C3. Suppose the first row elements are the sum of 2 terms, A1 plus alpha, B1 plus beta, C1 plus gamma. This is the determinant. What's the speciality? First row elements are all sum of 2 terms. Then this determinant can be written as the sum of 2 determinants. This determinant can be written as a sum of 2 determinants. How you know? First one, what do you write, you know? In the first row, you take first elements. What are the first elements? A1, B1, C1. Second row, A2, B2, C2, A3, B3, C3, right? First one is A1, B1, C1. Then second row A2, B2, C2, A3, B3, C3. Plus, in the second determinant, in the first row, yes, you guessed correctly, right? You take which elements? Second elements you take. What are the second elements? Alpha, beta, gamma. Second row, third row as it is. A2, B2, C2, A3, B3, C3. Now you read the property, you can understand. If each element in a row of a determinant is expressed as a sum of two or more terms, then the determinant can be expressed as a sum of two or more determinants. Since there are two elements, you are writing as a sum of two determinants. Suppose there are three elements, write it as three determinants. Okay, you can write, not necessarily always. If there is a need, you can write like this. So here in between the sign is what? Plus. So you put here plus. If everything is minus, you write here minus. But some plus, some minus, you write plus. Whenever minus comes, you in the inside you put minus. Okay, like that you can do that. And the last one, seventh one, you see. So I'll tell you what it is. Suppose one row is given A1, A1, B1, C1, A2, B2, C2, A3, B3, C3. So a determinant is given. Now it has some value. For example, its value say delta. Two rows can be added. First row and second row can be added. So that is A1 plus A2, A1 plus A2, B1 plus B2, C1 plus C2. Other things no change. Again the value remains same. Two rows we added, but still expand, your answer will be same. And what symbol you write, R1 is R1 plus R2, because this R1 we change, right? How we are getting this R1? This R1 plus R2. R1 and R2 you are adding and you are writing the new R1. New R1 means first row of the present determinant is the sum of first row and the second row. Even three rows you can add. R1 is R1 plus R2 plus R3. All the three you add and write. Again your answer is same. Or the second row you multiply by some number. Every element you multiply by same number. Then add it. Add or subtract, the value remains same. So when you do the sums, you can understand better. Okay, so this is the next property. The value of the determinant is unaltered, remains same. When constant multiples of a determinant, one determinant you can multiply by a constant, is added to the corresponding elements of a different row. So one row you can add to another row or multiply with something and you can add to the another row. Okay. Instead of addition, you can even subtract also. There is no change in value. Okay. So what we studied today, lot of theory part, very, very important thing. First, we studied what is minor cofactor. That is very important. Minor, you can write very easily. Leave the row and column, write the remaining, right? Cofactor, signed minor. We look into the sign also. If it is 3 by 3, plus, minus, like that alternatively. But 2 by 2, not like that. Plus, minus, then minus, plus. Okay, that you can check it. So, cofactor, minor, that's very important. Then after that, we studied the properties, some very important properties. When you interchange rows and columns, there is no change. When you interchange two rows or interchange two columns, it changes in sign, right? That we studied. Then there one important thing, cyclically you can rotate three numbers. Okay, three rows, cyclically you can rotate. There is no change. Why? What is happening there? You are interchanging two times. Okay, so there is no change in sign. Then in two cases, the value becomes 0. If two rows are identical, the value becomes 0. In the case of two rows are proportional, again the value becomes 0. Identical means exactly same. Proportional means some multiple, right? Then if you multiply some row, suppose all the elements of a row by a constant k, the answer also to be multiplied by k. Then two rows can be added, two rows can be subtracted, or multiply by some constant and add. There is no change in value. Okay, go through all these things. Based on that, we will do more sums the next class.